Now we are ready to understand DevOps. So having understood all the components, I wouldn't want to get into every component sitting into DevOps, because DevOps itself is going to be another big topic. So please understand that in DevOps, when you are implementing DevOps, the automation, you would bring in Kubernetes, you would bring in Docker, you would bring in Lambda, you would bring in virtual machine. All of those which are required to build your environment, you would use. The entire infrastructure which we have discussed would be used, automated in the DevOps. So what is DevOps? What is this automation of the software development lifecycle about? So the same set of whatever we saw, I've broken down into components. The design phase, developer writes the code, they build the environment, test it, and once everything is done, it is ready to be deployed. Then comes the release, where you do all your version tagging, feature freeze, code freeze, all those stuff. Deploy, build the infrastructure required, deploy the code into the infrastructure, and manage, monitor, give a feedback. And this entire stuff is automated. So since this is automated, every time there is a code change, a new feature is added, the developer changes the code and puts it here. The automation tool picks it up, uses the build tool to build it, test tool to test it, release to release, deployment tool to deploy, monitoring, managing tool to operate, give a feedback. Continuous. Every time there's a code change, the whole thing repeats. Another code change, whole thing repeats. Continuous integration, continuous delivery or deployment. The difference between delivery and deployment is very simple. Delivery is ready to be deployed, not yet deployed, waiting approval. Deployment is deployed into production. That's the difference. But the entire thing is called CI/CD, continuous integration, continuous deployment or delivery.
Vijay, what is continuous build? I mean, why do they need to? I mean, what is happening on the release? You're saying that the code is released, right? I understand this code and build that's continuously doing this integration and then the delivery side also. But
Right.
what is being released frequently?
Changes. Let me put it this way. You visit rjpinfotech.com website, or no, a better example will be Big Basket, which is my favorite example. If you have been shopping on Big Basket, you know that they give you offers from 1st to 5th of every month. And then there would be a different offer from 6th to 10th of another the month. And from 11th to 31st, there'd be a different offer. Right. So what happens? The content on their application changes. So this is what I can take as a very simple example for us to relate it to our own day-to-day life. So what happens? The coder would put all the new pages, new offers, etc. on the 31st or much before, and this would be ready for release, let's say on the 30th or 31st. But when would it get deployed? It would get deployed on the 1st of that month. So before that, it is just kept ready for deployment. All the other relevant test environment is done and kept ready. And once it is first, it is either manually approved or that is also scheduled approval or whatever, it is deployed.
Okay, so was this deployment not that quick enough as what is happening right now? Because the earlier times also we had the same release also, like talking about the traditional system of application releases.
No, but you imagine this way. I want to release a quick fix. We are talking about several releases per day. Do you think it is possible in a monolithic architecture, in the traditional non-automated scheme of things, the SDLC waterfall model? It used to be 1, 2 per few months or years.
Yeah, okay.
For that it worked. Not for such humongous amount of changes.
Okay.
Right.
Okay, understood. Thank you.
So I'm not going to brief this. I would be sharing this PPT. I would have an exit poll where you give your email ID. We'll be sharing the PPT, so you can go through this. I've already explained this. So what are all involved? What are the tools involved? I said it's automated. You'd be wondering, how is it automated? What does what task? So that's where this pipeline representation helps. The code is kept in a repository. It could be Git, it could be Bitbucket, anywhere. That's where the code is kept. And you would also have heard of this term version control. What do I mean by that? When one developer is among a team of, let's say, 100 developers on the same portal, this developer makes a change to his code alone, then only his file content has to change. Nothing else in the whole scheme of things must change. No other file, no other dependencies must change. Only the content of his file, the source code, must change. Right? He has changed the code to add a new feature and deployed it. It doesn't seem to work well in the production. It is not integrating well. With the new code, some functionalities are not working. So they are asking you to roll back. So what happened to the old code? That has been replaced by this. That is where version control comes in. When this guy is uploading his new file, he ensures that the old file is not destroyed. It is marked as old with a version ID and kept there. So any number of change he does is the same file with a new version ID. So all the files with the old versions are kept there. In case there's a rollback required, you can always roll back. So that's called version control. And all these repositories, your Git, etc., support version control. I'm not going to the details of Git. There is a lot of things like branching, merging, etc. So I'm just giving you one highlighted important significance of how things work, the version control. All right. Then the software, all the developers have put their code and their own files in the code repository. This has to be picked up and you have to build the application. You have tools like Maven to build. Once it is built, it has to be tested for functionality. You have your Selenium, JUnit, etc., which can be integrated to perform the test on the built application. Once this is done, it is ready for release if everything is working fine, and that has to be released and deployed in an infrastructure. The infrastructure could be, like we saw, it could be Lambda, it could be virtual machine, it could be container environment, it could be anything. So after deployment, it has to be managed, monitored, everything. So how do you manage the deployment environment? You can use Ansible, Kubernetes, or Chef. While Docker is the platform where it is going to be deployed, management of this Docker, if a container pod fails, how to replace, all those stuff is the headache of Kubernetes. So it's going to operate. You're going to monitor using Nagios, Splunk, Datadog, etc. kind of tools. If there is an error, if there is something that is to be given as an input, will be given back as an input for the planning phase, which in turn will inform the developer, and the whole process is cyclical. And who integrates, puts these things together in the right order? Not all stages are mandatory in all implementations, as we're going to see. But who is responsible for this entire set of integration and delivery release? The CI/CD tool. And the most popular CI/CD component is Jenkins. So Jenkins is responsible for integrating all these components, bringing them together, and automating stage after stage, step after step execution. Now, let's try to understand it in bits. The developer is going to create his code and put it in the repository. The moment he puts it in the repository, nothing else is manual. It will be automatically picked up by your Jenkins and passed on to Maven, which is the build tool, let's say. The Maven is going to build it, and if it fails, will send an email or SMS or whatever you have configured notification to the developer. In the earlier case, we said it is a planning. We're just bypassing that. I've just made some small modification. It notifies the developer, who understands that there's a problem with this file, and he rectifies the problem. So once the problem is fixed, so this is where versioning comes in. The same file name is now versioned. I call it version 1. Is passing the build, and then it is going to be packaged and deployed if it is container or whatever, and goes to the testing phase. Something has failed. Something is not acceptable. So that notifies the developer. So next, he fixes that error also, and then sends it for the manual testing, the user acceptance functional testing. So once it passes, it can go for deployment. If it fails again, it would inform the developer, who will have to fix that issue. That is also fixed. Then it can go for deployment. It goes to the Ansible, Kubernetes, or whatever component that you may have. It would do the deployment on container, Lambda, virtual machine, physical hardware, whatever. And then it will finally go for the production level. At production, if it fails, it has to be rolled back and again informed to the developer to fix the problem. So this is how the whole automated system works. If I have to talk about how this is done in AWS, now comes the AWS. AWS offers an entire set of equivalent tools. You don't need Jenkins. You don't need Maven. You don't need your deployment tool. Nothing. Everything is built into AWS. You don't need a code repository like Git. Everything is cloud native. You just get on board to the AWS. All the components which you might ask for is available. And one more piece of information that you must remember is that there are two different pipelines. One to build the infrastructure, because even the infrastructure is built using a code. That's called infrastructure as a code. So I write the code which says, hey, create a VPC, create 2 subnets, provision 2 EC2 instances, connect them to the internet gateway. All of that is written as code. And I keep that code in the AWS repository called the code commit. And this code will be used by another component of AWS called the cloud formation to build the infrastructure. And this is the demonstration that I'm going to show next. Okay. So once this is built, once the EC2 instances are running, you may want to run patch updates. The patch updates can be managed using the systems manager. Right? So this bunch of CI/CD pipeline is going to be managed by the AWS code pipeline, equivalent of Jenkins. So the code pipeline will define what components you are going to use, whether the built-in AWS components or the external Git, GitHub, Jenkins, Maven, etc. You can integrate all of that into the AWS code pipeline, and this fellow can build the infrastructure for you. Okay, the infrastructure building part is over. Now, what about the software which we spoke of? It has got, again, the same repository where the developers can put their code in the code commit. What is the equivalent of Maven? Code build. This will pick up this code, build the environment, build the entire application, and pass it on to code deploy, which will deploy this in your container, your VM, whatever has been provisioned by the cloud formation. So practically, you're going to have 2 pipelines. Once the application developers build the application code, The system administrators are responsible for building the infrastructure code, right? Both of them sit in the code commit. From the code commit, the code pipeline will automatically pick up and pass the application code to your code. Where is this? Code build is missing in this anyway. So the application code will be passed on to code build, and the infrastructure code will be passed on to cloud formation. So the cloud formation will create the environments, whatever you have defined. You may want one for development, one for staging, one for production. It will create all these environments. And when the application code is given to code deploy, it will deploy the application, whether it is meant for development, staging, or production. Appropriately, it will deploy. So in effect, you have two different pipelines which are running, right? So this is how the AWS implements your DevOps. This is how it will look. The AWS code pipeline allows you to define the source where you keep the code. It could be code commit, it could be Amazon S3, it could be GitHub, it could be Bitbucket, anything. You will define what is the source control that you're using. What is the repository from where you're going to pick up the code. And then depending on whether it is infrastructure or software, you will define the build stage. There is no build stage for infrastructure. It will directly use the code, use the cloud formation, and deploy the infrastructure. Whereas if it is a software, it has to pass it on to either Maven or code build, which builds the code and application environment. Once it undergoes the test, you can integrate the testing, JUnit, Selenium, whatever you want to, and then you pass it on to getting it ready for deployment, which is the staging. And after staging, it goes to code deploy for deployment. This can be highly customizable. How many stages you want here is your choice. What we saw is a generic model. We can customize it to our needs and requirements, right? So finally, the AWS part, please understand that these are the two different pipelines that we can come across, and one is for infrastructure and the other is for code deployment, the web application to be deployed. So that's basically what I would like to discuss. Otherwise, we will keep going on. Any questions before I proceed to the demonstration? Or can I proceed to the demonstration? Anything not clear? Anyone? Any questions? Or you can give me the go ahead, I can proceed for the demo.
I do not have any questions. We can proceed.
Okay, I'll assume that answer on behalf of everyone in the interest of time as well, and quickly proceed to the demonstration. So I'm going straight into my code pipeline. So let me choose code pipeline. I select the service code pipeline, and now I wish to create a pipeline where I can demonstrate what is there.
Screen दिखाई नहीं दे रहा है.
Yeah. Oh,
Screen
screen is
is
not visible.
yeah.
Oh,
Yeah, yes, sir. Screen is not visible.
just a moment, please. Let me know if it is visible now.
Yes,
Yes,
yes.
sir. Now it's visible, sir.
Okay. Right. So what happens? I would like to create a pipeline and I would want to put a code into my source control repository, the code commit. I would like to build an infrastructure. I'm going to do a very, very simple experiment of deploying EC2 instance using infrastructure as a code. So step number one, before I build my pipeline, I should have provisioned, or I should have created the code which is created in YAML in my example and put it in my source repository. You can see the source here. I'm going to make use of the built-in repository of AWS, which is called the code commit. And I click on repository. As of now, it's empty. So I create a new repository. Let me call dev repo. And I create that. What I'm next going to do is I'm going to upload my file which has the infrastructure EC2 instance creation code. I already have one. So I'm going to upload that simple file. I'll show you that file also so that you're able to recognize what is actually written. Just a minute, I'm just scouting for that code. Author name, I'll give my own name, mail ID, and I'll commit the change. Right? So here is my code. I've uploaded the small YAML file which says I want to create a resource which is my instance, which is a EC2 instance. Where do I want to create? In this availability zone, which is basically Tokyo. What is the image ID I want to use? This is the image ID, the AMI, a Linux machine, and I want to choose T2 micro. This is declarative in nature, where in moment I define this, I have not defined VPC, subnet, etc. It will automatically pick up a default VPC, default subnet deployed there. We will be able to observe that. So this is the smallest possible code I can imagine to create an EC2 instance in a public subnet. So my code is now ready, uploaded in a repo that I created. So I need to remember the name of the repo, dev repo, DNRCat. Done. So next, I'm going to go to my code pipeline and create a new pipeline. I will call it dev pipe. It will require some permissions to do some activities. One of the good advantages of AWS is every time there's a permission required, IAM permission required, it'll ask you if you want to create your own or should I do it on your behalf. You simply say you create it yourself, it will do it for us. So I'm going to use the default. What is the source? Where is it I'm going to pick up the code from? It is going to be picked up from any of these sources. GitHub, Bitbucket, S3, Elastic Container Registry. This is the equivalent of Docker Hub, or code commit. I have put my code in code commit. So I am going to choose code commit as my source. So where is it present? It is present in dev repo. And there is a concept of branch, main branch and other branches. So I have only one, which is called the main branch. So I'm going to use that. Change detection option. This is where it gets interesting. If I make a change to this file, it should be automatically detected, and immediately, automatically, the change should be implemented. Who is going to detect that? I will say allow code pipeline to detect that change. Then I go next. Since I'm going to deploy infrastructure, I don't have a build stage. It is not going to build an environment. So I can skip the build stage because I'm talking about infrastructure. And what is the component that will build an infrastructure from a code? It is cloud formation. So I'm going to use cloud formation in my pipeline for deployment. Where should it deploy? It should deploy in the Tokyo region. What is it that I want to do? I want to create a new environment. It's called a stack. I call it the dev stack. So where should it pick up? What is the file? Where should it pick up from? In the case of a software deployment, the source code is different from the one which is going to be deployed. The one which is going to be deployed is going to be called the artifact, and that's where they use the term artifact name. In our case, because it's infrastructure, I'm going to use the source artifact, which is in the dev repo. What is the file name? Let me just, yeah. Just give me a moment while I copy the file name. So this is my file name, ec2 public tokyo.yaml. I have already created a role with administrative privileges for CloudFormation to access the relevant resources. I configure that and I move on and I create the pipeline. So I've configured the source where I've kept the file to create the infrastructure, and I have also defined what is going to use this. And see, super. This is where I get to see the pipeline that I created. Source is in AWS code commit, and whatever code is picked up from code commit, I did nothing. I'm just passive. See what is happening. Succeeded. It has picked up the code and it has passed it on to the deployment stage. So it says CloudFormation is in the deployment component, and you can see that it is in progress. So if you want to see what CloudFormation is doing, I click on this. I think the screen will not show up for you. Let me unshare and share it again. You can see what CloudFormation is doing now. I can go to the events. It will show me whatever is happening. So it has completed creation of the EC2 instance. So let's verify that. I go to my EC2 and I can see that a new instance will be getting provisioned. Right? This wasn't there. It is initializing, you can see. So this has been provisioned by my DevOps pipeline. Fine. So let me assume I want to implement a change. I go back to my repository, dev repo, and upload a modified file with the same name. So I have kept the same file name with some changes in this folder. So I'm going to pick up this file. See, I've not changed the name. It's the same file name, but the content is different. So I'm the same guy who is making the change, and I say commit changes. You can see that the code has additional information. Now to quickly, let me go to the pipeline, my dev pipe. 2 minutes ago, it had picked up the code and it had deployed, right? I've just now changed the code. Let's see what happens. Succeeded just now. I've done nothing. This is the automation which I wanted to demonstrate, how the change automation happens. So immediately the new code is picked up automatically because I had defined code pipeline needs to detect the change, passes it on to CloudFormation, and the CloudFormation has started working in building again. This is just to demonstrate how things work. The automatic process of change management is what I'm demonstrating here. So what has happened is I have two versions of the same file. The first file with just the EC2 instance, second file with the EC2 instance and a security group added to it. That's what is the second version of the same file name. The moment I deployed it, it automatically detected and it is running. So if I wait till this completes, I will be able to observe one of the dangerous aspect about CloudFormation I have to mention here because that's what you'll see in the output. One of the dangerous aspects about CloudFormation is that it is destructive. It is not idempotent in the sense it will not make changes as per our desire. It will, in most of the cases, destroy the existing setup and create a new setup. So that's where you need to be careful what and how you're working with CloudFormation. Not for all situations is CloudFormation suitable. CloudFormation is suitable for creating new environments. Or if there's a change which does not affect the existing environment, then that's fine. So it says now succeeded. So let me go over to the EC2 instance section and see what has happened. You will see exactly what I told you. It has terminated the old instance and has recreated a new instance. This is how CloudFormation implements changes. So that's basically what I had for demonstration. Hope you got